Yeah, so welcome to my talk about GitHub Actions. So I'm here at that conference actually for the third time. So it's probably one of the best, if not the best, conferences I know about. Who is actually here for the first time? Great, I guess you will love it as well. Yeah, and that's also the place where we could thank our sponsors, without whom it would not be possible to have that conference experience. Yeah, just use your time and check out the sponsors at the booth outside. They have great offerings, some have prices. I think you will like that as well. Yeah, a couple of words about me. I'm Bas. I live in the Netherlands. I'm working as a software engineer for a biotech company. If you want to connect, all my links are on bas.bio. And yeah, today I want to go and talk about GitHub Actions. So who of you has already used GitHub Actions? Okay, probably half of you. So who knows what it is or doesn't know anything about it? Okay, that's a good start. So we will have a look at what it is actually, how it compares to similar tools. We will have a look at what triggers an action ran by GitHub Actions. We will create a couple of jobs and workflows on our own. And yeah, I just brought a couple of examples for that, which are a little bit outside the usual context, a little bit outside the usual CI/CD stuff, just to have some more fun with that. And then we have an outlook on what's more to GitHub Actions. So GitHub Actions is actually the product name of GitHub's CI/CD tool. So that means that it's a tool where you can define workflows which are defined within your source code repository. And these kind of workflows can run against any entity that is provided by GitHub. So entity in that sense means it's not only your source code, it's also issues, wiki pages, pull requests, all that kind of stuff can be automated with GitHub Actions. So the usual workflow that you use it for is build, test, and deploy. So whenever a commit comes in or a pull request gets approved, some automated tests run, the pull request is merged, and finally it gets developed to staging, production, or testing environment, whatsoever. And as I said, today we're going to have a look at more of the unusual examples to use GitHub Actions. So GitHub actually was a little late to the shows. There were other tools like GitLab CI, Travis CI, and Circle CI, and of course, the well-known Jenkins. So GitHub had the chance to learn a lot from what these tools did right and what these tools potentially did wrong. So what all of these have in common is that you place your workflow definitions in your source code repository. And one of the major differences to other tools, at least when GitHub Actions launched, was that these definitions wasn't in a single file like a Jenkins file, but GitHub watches for an entire directory in .github/workflows, which enables you to basically have a couple of different workflows live independently of one another in your source code repository. So as I already said, there are a lot of things, every entity of GitHub that you can automate with GitHub Actions. So there are a lot of things that can trigger an action to run. So like pull request command, or my favorite is Golem, which actually refers to the creation of a wiki page in GitHub. But the ones we will look at are mostly like push, issue, schedule, and workflow dispatch, and we will later see what these are. So to start with, a workflow is actually defined by a YAML file inside that .github/workflows directory. It gives your workflow a name with the parameter name. In the parameter on, you define your triggers. And then you have a definition of jobs. Each job has a collection of steps. So the hierarchy here is you have a workflow, you have a job, and each job has a couple of steps. So it wouldn't be automation if we couldn't substitute any variables. So there are expressions in this YAML file, which looks like a $sign and then curly brackets. And inside of that is an expression that on run gets automatically replaced with whatever value you have. And the context where these values come from can be either be GitHub, env, jobs, steps, or secrets. So basically, these are containers for your variables. You can define secrets, which you might need for storing secrets to push to production. You have the context of GitHub, which contains basically your tag name or your commit ID and stuff like that. We will see how they work later on. So, and another important feature are matrices. So sometimes, especially if you want to have some natively compiled code, you might want to run that on Windows, Linux, Mac OS, and on different processor architectures. So what you can do is you can create any combination of different variables, in this case, OS and architecture. So that would give us how many combinations, if I define it that way? 6. If I added another one, like with 2 possible values, that would like be 12. So GitHub is able to run all combinations of whatever variable I define there, just in iteration, or even in parallel. So that should be enough for theory. I brought a couple of examples, and the links to the repositories you find on the page for this talk. So probably you can just scan that QR code, and yeah, then we dive right into it. So let's start with some stock example. 1 second. So you all have that page now? Perfect. So let's start with the first example, which is called stocks. So this should be a repository where I define a couple of ticker symbols for stocks that I might own, and I could use GitHub Actions to automatically pull the current quotes. And then I have GitHub Action to actually render some charts of these, and all that should be done automatically. The good thing is I would not have to run any cron jobs on my own. I could just use GitHub Actions for that. So, and as you see in the commit history, this is actually what happens. So I have a bunch of automated stock quote updates here, and these were triggered by my workflow. So how would that look like? So as I said, we start with a name for the workflow, which is update stocks data here. Sure. And then I have my triggers large enough. Okay. Then I have my triggers in the on section here, and this specifies that this action runs whenever I do a push to that repository. It also runs on a schedule, like at 6:30 p.m. on every weekday, with the exception of Sunday and Saturdays. And I have workflow dispatch, which basically means that there is a button in GitHub on the GitHub side where I can just click run. So, and then I define the jobs, actually. So I specify that that there is a data workflow, which runs on a Ubuntu machine. In the current working directory app, that refers to the directory inside my source code repository. So, and then these steps basically do whatever is needed to be done to set up a machine, to install dependencies, in this case Python, which is what I use to update my stock quotes, and then actually runs the scripts that I have that use Y-Finance to actually pull the data. And then at the end, I want to commit these changes back to the repository so that the repository contains a CSV file for each ticker symbol with all the stock quotes inside of it. So I don't want to get into the source code, just really quick. Inside the app folder, there are just like a couple of Python scripts, as I said, which just get the stock quotes. And then let's see what happens when actually a commit happens. So I click here, and I see, OK, there is obviously a new row for my CrowdStrike ticker symbol. And I use GitHub actually to display the differences here, which is a quite clever idea, and I didn't come up with that on my own, but rather there is a guy called Simon Willison who came up with that idea quite a time ago, and he calls this technique Git scraping. So the idea is that you have a public or private data source which updates regularly, and that you pull the changes and use Git history to actually track these changes. So this guy also has some interesting tool called Dataset. Does anyone know about Dataset? Yeah. Where you can just, in your browser, visualize any CSV file, for example, which lives on GitHub. And you can then use Python and SQL to just query your data, and you see, OK, there was a power outage here, crew is on site. And you get these updates from PGE. And that's probably something, if that's the reason you're into GitHub Actions, like accessing data changes, you might want to have a look into that. I cloned the repository. There's this link to this dataset lite, which on the fly gets the CSV file, so that might be interesting. So, OK, there is another thing that you could use GitHub for. So let's say you have like a form which takes in some data from visitors, and you want to enrich these data. For example, you want to have a podcast directory. Like you have a website where people put in their favorite podcasts, you download the cover image, and just display them on a site. So you could use entirely GitHub for that. So which is our third example here, called Podcast Collector. Just give it a moment for those of you who want to check that out live. So this doesn't look like much. It's just a list of some podcasts here in that README file. And these come from a data directory called podcast. There's a YAML file for each of those podcasts. For example, if I look here, I define a couple of variables like a name, an RSS feed, and there is a service called Podcast Index, which is basically an open source database that manages podcast data. I get the ID from this service to further enrich the data set. And yeah, then I use a GitHub action to actually create this README file. But there's more to it. Like in the .github folder, there's not only your workflows folder, there's also something called an issue template. So this enables you to create a custom issue type where you can just define how a form would look like if you create an issue on your GitHub repository. So in this case, I want the issue type for new podcast. I give it a tag of add podcast, and I want the podcast index ID as an input. I want the name of the podcast as an input, and I want a list of tags as an input. So, and then let me get that running, and then we see how that works. So I go to issues here, I click new issue, and this new podcast issue type pops up here. So if I click on get started, it gets me the form that I have just created in my issue template definition. So if I put another podcast in here, like let's say commit your code. Give it the ID I needed to look that up. It's 124455, and the name is commit your code. And this is all about web development and JavaScript. Yeah? Okay, I submit the issue, and let's see. Okay, there is this issue. And let's head over to the Actions tab. Let's see if there's something running. Yeah, there's an action that just was triggered by me creating that issue, and now it's running. And what it does is it adds the podcast. So based on the idea that I gave it in the issue, it now goes to the podcast API, looks up the image, looks up some metadata, and then commits it back to the YAML file. And once it's in the YAML file, it automatically creates that README file. So obviously that worked. Let's see if we see it. And there it is. Commit your code. It gets the description from the API, it gets the image from the API, and that's all fine. Good. So now that I have created like just a README file in a GitHub repository, that doesn't sound much. What if I want to create like a static website for my podcast directory? So we could use a static website generator like Hugo or something to create like a static website like this. And there it is already. So basically what happens is I used another trigger to create the run of a GitHub action in another repository. So let's have a look of how that would look like. I go to the workflow page of workflow directory of the collector, and there is this add podcast, which just is ran on any issues that has a label, in this case, add podcast label. And at the end, there is something called GitHub script, which now, creates some interaction on the issue that I created. It closes the issue, it auto-commits then, and it then triggers a dispatch to another repository. It says, okay, there's the repository containing the Hugo application. Please take the dispatch from that repository and do the update. So there is an event type called podcast update. That can be any string I want. I just need to make sure that on the other repository, the same string is used. So what that does actually is, get me the other repository and run a GitHub action there with the label podcast update. So there must be another GitHub action on the other side, which we will look at later. What is interesting here is I need a secret for that, which is a repository dispatch token. That is nothing fancy, that's just your personal GitHub access token, which needs the permissions on both repositories, obviously. So, let's go to the Hugo app. Let's see how the workflow looks there. So there is a workflow called sync podcast from external repository. And there it says, I run on any repository dispatch, which is what I just did, with the label podcast update. So this is what I expect. And then I go and check out Python, install Hugo, and generate basically my static site. So these kind of things make complex workflows between repositories quite manageable, because as you see, it's just a mere 50 lines of code, and most of it is just configuration for what operating system I want and stuff like that. So that's pretty cool. So another feature that GitHub Actions have is you can create something called artifacts. So when you're running your action, you can create any kind of data, like CSV files, like test reports, like whatever. And you could also create videos. So what if you have a front-end project and you wanted to use, for example, Playwright to use a visual testing for that? What I did here is I created a Playwright project, defined some tests with some specification. Okay, I go to the Playwright page and I expect the page to have any title which contains Playwright, and then I click on a link, and that's basically it. That's basically front-end testing in its basic level. So when I change that, or any test case here, I can create basically an artifact, and I have a Playwright report here ready to download. And let's download that. And there we are. I have data here, and there is a WebM file, which is just the video of Playwright clicking through a web page. So that's probably cool if you want to catch up with your testing team in an automated way, so that on every source code change, you get a video for someone to manually inspect just from the GitHub Actions tab. So that's also one use case. So another one, again, like a little bit of static site stuff here. What I did is I created basically a template repository to build a resume page. And there is a special feature of that, which is it gets you the same resume page as HTML in the browser, but it also gets you a PDF in A4 and US letter, which is automatically generated from basically what you put in here. There is a config toml, and you just define your work experience and stuff like that in a toml file. Hugo is going to pick up this toml file, create the HTML version, and then the GitHub action goes and posts all that to a third-party service like pdf.co, creates the PDF files, commits these PDF files to the repository, and publishes it to GitHub Pages or Netlify or whatever you want. So let's see how that would look like in the workflow definition. Again, we give it a name. We define that it runs on every commit to the main branch. We define a job running on Ubuntu. And what we do is we set up Hugo, and then we just build the web page, and then we use a third-party application, here, like a Netlify CLI, to deploy it to Netlify. We generate the PDFs from the live web page, and then we commit these files back to the repository, and then we push these changes. Okay. That's pretty neat too. So if you are less interested in static site generation and more interested in what can you do actually with your code, you might have the case that you have a mono repository or like a closed source repository, and you want to make parts of that repository public. So let's say you have like a mono repository that contains a directory called scripts, and you want these scripts to be published in a public repository, but everything else not. So, but your developers should work in the mono repository, right? So how would you sync these two repositories, like the public one and the closed source one? You could, surprise, create a workflow for that, running on the mono repository, which just checks out whatever is in that mono repository, go for a path called scripts, because that's the one you want to publish. And then check out the target repository as well. Cherry pick basically every commit that you have in the mono repository, publish it to the target repository. And this is just a bunch of shell script. I don't want to get into the details of shell scripting here. And then push it back to the target repository. And again, you would need a personal GitHub access token with permissions to both repositories, otherwise it won't work. So how would that look like on the other side? Let's go to the target repository. And you have the exact same commit history as in the mono repository, just you obfuscated the author, but you get the original commit ID delivered to it. So basically this is one-on-one in sync with your mono repository, but just for the part that you want to be public. Okay, so far any questions? I know that were a lot of examples for now, but I hope you could follow. Are there any questions so far? Yes, exactly. So of course you could change the shell script to do whatever you like if you have the secrets, like the signature keys and stuff like that. Okay. So here's one example which is a bit more on the traditional side of CI and CD. There's a simple Hello World program written in C, nothing fancy, just a couple of lines of Hello World. And let's say you want to compile that, but you also want to make a Debian package for that. And on top of that, you not only want a Debian package, but you want to set up an entire apt repository so that people could just add your apt repository to their sources list and install your package from there. So how would you do that? So basically, there are a couple of steps involved. First is compile. Second is build the Debian package around that, and then set up the apt repository as a static website. And we use GitHub Pages, which is a feature where you can publish static websites on your GitHub account for free, actually. And you just have to follow some conventions of Debian for the apt repository to work. So let us look at the workflow here. There's a workflow called build, which does exactly that. It sets up my Ubuntu, installs the build essential, which I need to package a Debian repository or Debian package. I just run cmake to compile my Hello World application. Then I create the Debian package by just creating a control file, which just gets a bunch of metadata added to it. And then I run actually the dpkg debian build command to put that in a .deb file, which would be an installation file for Debian. And then I would need basically, the structure of the apt repository. And turns out there is a third-party action which just creates me an apt repository and publishes it to GitHub Actions. All I need to do is, I need a personal access token, and I need a GPG key for that apt repository to be signed. So I can store public and private key and my GitHub secrets and have that action do all the work for me. So let's see if that works. Let's go to the README file. There is now an apt repository that lives here in my GitHub Pages under the name of the repository, and there is a subdirectory called repo, which contains all the Debian-specific files. You have to believe me that it is really there, because GitHub Pages doesn't allow for directory listings, which is why you get a 404, but it actually works. So I needed to come up with a technique to actually prove you that it does work. So I could create a Docker file, which just adds this apt repository for me, and then installs my Hello World package from that apt repository. And I could show you that on my local machine, but I won't. Because we could use GitHub Actions for that as well. There is another workflow definition here, which is just run the Docker file in the repository. All it does is it runs on Ubuntu, it installs Docker from the Docker source code repository, and then it builds and runs the Docker file. So let's have a look at the Docker file. The Docker file just goes and gets the public key from the repository, which is just the GPG key I talked about to sign the repository itself. And then it adds this GitHub Pages repository directly to my sources.list. And then it installs my Hello World application, which is the one that I just compiled, and it runs it. And now if I run that Docker file, I should see the output of my Hello World applications. Back to the run Docker command, we see that the trigger of this is just a workflow dispatch. And again, this is the method that allows me to run it by click manually. So I head over to the Actions tab, and I see there is an action called run Docker file with apt repository. I click on that, and then I have here a run workflow button. I click that. Then I need to refresh the page, thanks GitHub. And I see here the log output. So it now waits for, it got a runner. Now it checks out the code, sets up my environment, downloads Docker, installs Docker, and all that stuff. Give it a while. Then it builds from my Docker file. And it runs Hello World in version 2.0. So basically, this is the proof that I just installed a package from an apt repository living on GitHub Pages, which I've just compiled. So if I head over to my VS Code now, and change that to version 3, whoa. And then I tag it with v3.0.0, and then I push the tags to GitHub. I should be able to see the latest commit and like a brown button, which is indicating that an action is running and waiting for a runner. So I head over to the Action tab, and now it's building. That should take probably a minute or two, so you might want to check later, run Docker file with apt repository, if that actually reflects the version 3.0. So, yeah. So they have, we will come to that later. You can specify the machine type that you want. So you can have a quad core instead of a dual core virtual machine, for example. They also have a lot of stuff for caching, so that you can have a build cache that lives or is persistent between different job runs. And you also can use custom runners, so that's basically a server that you operate by yourself that could also live like inside your local network. So that way you would circumvent one limitation that GitHub Actions has, which is it doesn't have access to your internal resources. But the moment you employ like a custom runner, that could live anywhere you want, as long as it has connection to the internet and therefore to GitHub. So there are a couple of options, and there are also like some startups providing services to actually make GitHub Actions run faster. I have some examples later on. So then there is a special repository that I do care about a lot because I'm working on a project which is about standardized development environments and cloud-based environments. And one feature that I love is dev containers. Who of you is using VS Code? Oh, okay. Who is using dev containers? Oh, that's not too many. Who knows what dev containers are? Okay, let me explain. The idea is that you have a container, basically a Docker file as a definition, that sets up all your development requirements, like interpreters, compilers, tooling that you need. And you run VS Code inside that container so that every developer can just use that container to run their instance of VS Code, and everyone is on the same page. So the only problem is that these containers take a long time to actually build. The more complex your tool belt is, the longer they take to build. So what if there was like a solution to it in the form that when the source code changes or my definition of the tools or dependencies that I have changed, that I build this development container remotely and use that remote container actually in my local workflow. So this is exactly what we do here. So the way it works in VS Code is a couple of extensions. I have a folder called dev container, .dev container. This is not related to GitHub Actions. This is related to VS Code, actually. So inside that .dev container folder, there is a file called dev container JSON, which looks like this. It basically defines that I have a Docker file, which contains, in this case, whatever I need to do Python development. And this Docker file is used by VS Code to actually run VS Code in that container, and then I can use it. So let's have a look at that Docker file. It does a bunch of different installations from apt-get upgrade, from apt-get. I don't want to get into the details, and probably most of them I don't need. I just want to make the point that this Docker file can become as complex as you want it to be. So we might need a way to run that faster. And I chose Python as an example because I use pyenv to set it up, which basically means that pyenv is going to fetch the source code of the Python version I just specified and compiles my Python interpreter. So that takes ages. I don't want to have that experience when onboarding new developers to a project. So I really want this to be done by my CI tool. So if I go here in my VS Code, it automatically provides me an option, reopen in container. And if I click that, it connects to the Docker daemon, runs it, and it looks like before, with one exception, I'm now on a Linux system. I'm now inside this container and not anymore on my usual macOS shell. So this is actually the power of dev containers that you have. You just give the Docker file to someone else and they are ready to go. including not only for running your project, but including developing for your project within their favorite IDE. So what VS Code does is actually it inspects this dev container JSON file and builds a container based on that specification. And there is luckily a tool called dev container CLI, which does the exact same thing VS Code would do, just on the command line. So and I use that in GitHub workflows to actually do the exact same thing here. I just set up my Docker, and I pre-built my container image with the dev container CLI, and I say, okay, cache from that, and then I push it to the GitHub container repository. And the next person who checks out my code can just cache from that GitHub container repository image. So basically, that what you would like to see is this one here. So before it looked like that, and introducing the caching, you see that all the layers that the Docker file contains that I needed to set up my development environment actually got cached now. So another example would be like publishing open source packages. So again, I chose Python for the demo here. I have a package on PyPy called bash codes, so that you can run pipx, run bash codes, and get my contact details on your terminal. So, and what I want to do is I want to have the Python files packaged in the Python wheel format, publish that to the Python package index, and I'm ready to go. So you actually can find it there. And there are tools for like most of the open source repositories like NPM, PyPy, and whatever you like. The good thing is you can really integrate that into your CI, so you can have your version management in your GitHub account or on the organization's GitHub account, whatever open source organization you are contributing to. And then, yeah, basically you're good to go. Let's have a look at that workflow. Again, this is very simple. It's just like it runs a make build, which is basically Python, or there's a make file which calls Python tooling to actually package this thing, and then it uses a tool called Twine, which publishes that to the Python package index. So basically that's it. So let's go back to the dev container example and have a look at what actually how it actually looks like if you run a GitHub action. You have all your steps coming up from here, and then there is a bunch of log output that you might see, and this can become overwhelming really quick. So you want to collapse individual parts of your log output as well. Like in this case here, run docker setup build action is actually a little bit longer, a bit more of a log line than just that. And this is actually something that you can easily employ just by taking care that you have what is called an echo group in your GitHub actions, which is just basically an echo, followed by a double colon and group colon, and then it just gives you these collapsible log messages. Everything between group and end group is below one of those arrows, which makes the log output much more readable. And then there is another hack to GitHub Actions actually. So usually you have something like that, like a dependency of your jobs, but you don't have an indication on where your steps are. So for example, install Python might have some sub-steps, but you don't see it visually, what the state of these are. What you really want to see is something like that. Like for each individual step, you have like a progress bar. So for some strange reason, this is implemented in GitHub, but it is only usable if you specify a deployment target. So usually you can set up environment variables for your GitHub Actions, but you can group them. You could store secrets like to publish to production. You could have another environment published to staging with different credentials or something like that. So, but the moment you use this, the moment you specify any of those environments, for some strange reasons, the sub-step progress bar appears. If you leave it out, it disappears. Nobody knows why. It seems unrelated, but if you want to have your steps displayed, just put environment : and whatever you would like there. That's also something I stumbled upon. That's.
You simply just specify what you have highlighted there.
Yes. Yeah. You specify that in every step, awesome. And then you get these buttons. But if you leave it out, they're gone. Strange. Okay. So there's one last thing I wanted to show you, that the stuff about matrices that I already talked about. So here's an example of another Hello World application, this time written in Go. And I want to have that built for Linux, macOS, Windows, on x86 and ARM. So what I do is I create the build steps for each of those combinations, which again, as we already pointed out, would be 6 steps. I compile it, and then I want to have a GitHub release. A GitHub release is basically what you see here. I want to release 1.0 and have all the compilation targets as artifacts here, ready to download. So the way that works is first I do the compilation steps. So then I have a binary for each of those 6 combinations. Then I upload the artifacts to GitHub. Again, the artifacts are like bound to GitHub Actions. They are not published, even not on a public repository. They are just ready to pick up for another action. So what I would need as a next step is make that public, which means I need to create like a release, which is actually what happens here. I create another job definition called release. I specify the dependency to the build job, run it on Ubuntu latest, and say, okay, just create me the release. At this point in time, the release is just empty. The release is empty, and it has a URL, like an encrypted URL, a secret URL that I can use to publish individual files to. So I would need that URL in my next combination of steps. So I specify that the output of the whole job here should have a key called upload URL, which is then the output of the create release step, and there the encrypted URL. And then I need to get again the files from the artifacts of the release job, pick them up, and post them to this encrypted URL I just had. So this one again runs on this matrix strategy, like with these 6 combinations. It goes and takes, okay, again, I specify the dependency to the release job, and then I specify the upload URL just by a reference to the needs, which is my dependency to the release job, to the outputs, and then the upload URL, which is exactly what I defined here. And the way that this matrix strategy runs is, again, like each combination run individually. So I use the variables there to just pick the right file from my artifacts, rename it so that it doesn't have a release called Ubuntu, but rather a release called Linux and a release called rather Darwin, or rather macOS and not Darwin. I do some renaming here, find the file from the artifact and publish it to the GitHub releases page. So, and then basically I'm good to go. I have my release 1.0 here. And this source code in zip and tar format, this is what I did not specify. This is what GitHub does automatically. So whenever I create a release, it automatically contains the source code, and every other file I have to specify manually. So that's it for the examples. So far we have seen, like, most of the time like pre-built actions, like actions/checkout. That is an action that was provided in this case by GitHub, but there is also a marketplace for different actions where third-party authors can provide individual actions. So how could we create an individual action? Okay, we could just use the run action and specify a bunch of bash scripts or PowerShell scripts, but we could also use JavaScript to make a GitHub action. We could also use a Docker file, or we could use what is called a composite action. For that, we would just create a repository with an action.yaml. And in this case, we are not creating a workflow, but we create an entire action. We give it again a name. And in the case of composite, as the name suggests, we are just composing different existing actions together to have one composite action. I don't want to get into the details here. If you want to create your own action, probably the easiest way to go is by using Docker. There's an excellent starter tutorial on GitHub itself. There is a Hello World Docker action that you can just use. All of that with like everything baked in, like inputs and outputs and access to secrets and what you may need to actually proceed with your action. You are not limited to JavaScript if you use Docker. You can use whatever you want. So, and again, as for custom actions, there are also custom runners, which we already briefly talked about. The idea here is to provide a virtual machine, which is used to run all your workflows instead of the hosted runner that GitHub provides. And again, the advantage here is that you can integrate it in your existing infrastructure. You don't, of course, don't pay per minute then if you just put your bare metal server in the basement and connect it. You can run as much actions as you want. You can also run on any operating system, including macOS, which makes some interesting combinations possible for people developing iOS applications because they can run natively Xcode. Is anyone using Xcode for iOS development? No, Nate? Yeah? You have any remote builds or something? Or do you just compile locally? Okay. What are you using? What are you using that for? Which service? Self-hosted? Okay. Yeah. So again, and not only macOS is an issue, you could also add like server with a different architecture, ARM, for example. And again, here there's one example of one of those startups that provides custom runners for you, one of which is Warp Build, and they basically do some magic to accelerate the GitHub Action experience. So as for the Mac builds, GitHub now provides some Mac runners on their own. Turns out they are quite expensive. So the pricing of GitHub Action is very generous in the free tier. You get like 2,000 minutes just on the free account and 500 megabytes of storage. Storage in that sense is whatever you put to your artifacts. And on GitHub Pro or for organizations you get, or enterprise, you get much more. But there is a multiplier. So if you run your GitHub Action on Windows, you pay double the price, or you have just 1,000 minutes instead of 2,000 for free. And the multiplier for macOS is 10. And probably that's just because, I think Mac Minis are quite difficult to stack up in a data center. And I don't know.
Is that your constraint for cron as well? So like, if you were to use a cron job and just say run it every second, that would be the limit to how much it would actually be able to run?
Well, yeah, I mean, if you have a cron job that runs every second but just takes half a second to run, then you have 1,440 seconds. Do the math on your own. It's quite difficult to do that on stage. But whenever the workflow runs, that counts as a second. And I think the precision that GitHub does is to the second. So, and yeah.
It's, you pay per minute, and it's a minimum of a minute.
Really?
That's what I thought our
Really? Okay.
telling us.
Yeah, thank you.
Minimum of a minute.
Okay, so then probably it's better to not run secondly cron jobs. So does it apply to the free minutes, or is it just for those paid minutes?
I don't know. All I know is that our team that works
Uh-huh.
with us more was saying, you can run something, but it's going to charge you at least a minute
Okay.
against the allocation that they have for that
Okay.
structure.
So probably that, yeah. So if you use more than 2,000, this is the pricing table. I think it's still pretty okay-ish, and you can always circumvent that with a custom runner.
The nature of the conversation I had with them was like, there's steps within a job, right? And the job has the runner is like the machine that spins up is by the job.
Mhm.
So if you had like a handful of things you wanted to do, you could do them in serial or whatever on the same job, then that 1 minute still applies to that. Versus if you had like 3 jobs.
Yeah, exactly.
That's 3 minutes that
Yeah.
you're using up now because you have 3 different jobs doing
Yeah.
it.
So yeah, that's a good point. Like the hierarchy I mentioned in the first place was like you have a workflow, and this workflow has jobs, and these jobs has steps. So of course you could do anything like as a combination of both, like just specifying the dependencies, and then you're good to go. But you're right in the way that better do it whatever you can do as steps and not as jobs, because each individual job run would trigger another billing event, basically. So probably one of the other things that GitHub did after being acquired by Microsoft is getting a bit more enterprisey. So of course they offer now a certification to the general public. I think that's quite recently that they opened it. It's just a couple of months ago. And I'm just trying to get my head around what's in there. I've not yet taken it, but I plan to. And I also are in the process of creating a mini guide that you could download. It's not yet ready, but I send it for free to you if you just put your email address on that page again. Yeah, probably someone after the conference and after traveling back. Okay, that's basically it. Again, the link. Are there any questions?
Ross, how do you handle testing or proving out GitHub Actions locally? Is there a way to test them locally before?
Yes, I mean, that's a common pattern that you see as like your commit history gets, okay, GitHub action 1 and 2 and 455. There is an open source package that claims to allow you to run it locally. I forgot the name, but the last time I checked it, I found it was not really stable. Yeah, there's, to my knowledge, not a good solution by now.
I think it's called ACT.
What is it called?
ACT.
ACT? That might be. Yeah, have you experience with that?
No, we do it the hard way.
Okay. Okay. Any other questions? Good, then thank you.